So, what we're going to be doing over the next couple of lessons, we're going to watch a series of videos where we explore what happens when we heat up certain substances. Now, I'm sure you've already got a few good ideas about what will happen when we heat up something. The substances in question are all going to be solids, so you might expect that they're all going to just melt, and then maybe if we heat them strongly enough, they might even go on to boil. But what we're going to discover is that some of these substances actually don't boil. Some of them won't even melt, not just because the Bunsen burner is not hot enough, but because there are other changes possible, chemical changes, rather than just the simple physical changes of melting and boiling, and if we cooled it down, presumably condensing and freezing as well. So that's what we're going to explore over the next couple of lessons with the help of a few videos. We've got 8 substances, and we'll look at those when we're ready to. As we work along, you're going to be watching these videos. There'll also be tasks for you to fill in either as you go along or afterwards. And of course you can watch the video a number of times if you need to. So make sure you know what the task is that you're supposed to be doing alongside this video and other videos which follow. For example, the first couple of weeks, the first 2 lessons, we're going to be making observations, and it'll be your task, with our help a little bit, to write down what you observe happening. What does the chemical look like at the start? For example, one of the chemicals we'll be using here, maybe I'd describe it as a green powdery solid to begin with. What will it look like at the end? Well, we'll find out. And what does it look like in between? In other words, how can we describe the change, if any change occurs, from start to finish? How might we describe the process? What else do we see, or any other interesting observations? So the first thing we're going to look at before we get cracking with actually observing what happens when we warm up some substances, we're going to have a quick think about what pieces of equipment we're going to use. As you can see, I'm wearing my goggles, as we always should be when we're working in the lab. Our source of heat is going to be the good old Bunsen burner, and so I've also got my heat-proof mat ready to protect the table from anything hot, i.e. the Bunsen burner. We're going to need a way of suspending our substances in the flame for long enough. And it doesn't seem very sensible that I should be holding it there for a prolonged period of time. And so I'm going to use a clamp and stand. So I've already set this up. I've got my stand, my boss, and my clamp all ready to go. Now, most of the chemicals that we're going to be studying are powdery solids. And so what I'll need to do is I'll need a way of getting these solids into the heat in a way that we can see them, and in a way that they get heated effectively and I can handle them safely. So I'm going to be using boiling tubes. Now, let's never get boiling tubes and test tubes mixed up. They're essentially the same thing when you look at them, except boiling tubes are made from a tougher material, normally made from something called borosilicate glass, the same sort of material that our beakers are made of, and we know we can heat those very strongly. Sure enough, as the name suggests, we can do quite a lot of heating in a boiling tube. I'm going to put my boiling tube in the clamp. I'll then position the boiling tube so that it's going to be held directly over the Bunsen burner flame. And of course, the advantage of using something like a boiling tube, something transparent, is that we can see what's inside, so hopefully we'll get a really nice clear view of what happens. Now, some other things for you to think about. Why do you think I've angled my boiling tube in the way that I have? I could have just held it with some test tube holders. Instead, I'm choosing to use a clamp. But on top of that, I'm pointing it, well, over there somewhere, relative to where I'm standing and relative to where anything else around me that I might want to protect is. So have a think about why I've done it like that. Okay, so here we go with our first chemical then. It's time to get started on this. Our first chemical is sulfur. Sulfur is what I describe as a yellow coloured powdery solid. I'm going to use this spatula to transfer a small quantity of sulphur into the boiling tube. Now, bear in mind the sorts of observations that we're expecting you to try and make here, depending on what you actually see. We'll use the table you've been given. There's clearly a space where you're going to describe the appearance of the material before it's heated. I've given you it this time. I'm saying it's a yellow coloured powdery solid. You're going to have to use your own judgment and listen carefully to what I say for the next couple. There's also a space where you can record the appearance of the substance after it's been heated, and there might be a number of things that you feel the need to say there. Then there's also a section for other observations. For example, you might comment on, well, anything else that you feel is noteworthy, and I don't want to say too much. So here we go, here's our sulphur in the boiling tube ready to be heated. Let's find out what happens when we heat it up. So think about what you can see. There's obviously a change of colour. Do you think that there's a change of state as well? Note down what you think you're observing right here. So we'll watch it for just another couple of seconds in case anything else interesting happens. Now, there's obviously a change happening here. It's up to you to decide what you think that change, or how you might best describe it. I'm just going to point out, I'm going to turn the heat off now. As well as the obvious changes in colour and possibly in state, I think there's definitely something worth considering when we look at the fact that it's gone cloudy up here. If we can't see through this transparent glass, there must be some kind of thin layer of solid, presumably, covering up the inside of it. So not only have we had the change down here, but over time, as it continued to be heated, there might have been a further change that led to whatever this is here. Have a think about what you think might have caused this yellow solid to make it all the way up the tube like that. Now, I'll give you one more observation. I'm starting to smell the faintest whiffs of quite a pungent, maybe slightly acidic smelling gas. And because of that, I've turned the heat off. It's time for me to put this one in the fume cupboard where it belongs. Okay, so that was very interesting. On to our next chemical now then. It's time for some zinc oxide. Zinc oxide, when I look at it here, appears, well, it's definitely a white solid, very, very powdery in its sort of texture. So as per before, let's warm up some zinc oxide. The first thing I'll do, just a couple of spatulas of this powdery white solid going into our boiling tube. Let's clamp it in place, ready for applying the heat, and off we go again. Now, sometimes patience is a virtue in chemistry, and it might at first appear that nothing's happening. However, I know that something will change eventually, so let's keep watching, let's be patient. Now, there's some sort of change creeping in there. It's up to you to describe what you think you can see. I'm going to turn the heat up, so now I'm going to increase the heat of the flame by advancing it up to the roaring flame. We'll have to try and ignore the colour of the flame around the bottom of the boiling tube. That's just because we've got very hot glass there as well now. We're interested in the contents of the tube, don't forget. Now I'm going to take the heat away completely. So there's clearly been a change in the appearance of that solid. Let's now let it cool down for a while. Let's see if there's anything else that we might observe. So during the heating, we've definitely noticed a change. What about after heating if we allow it to cool down for a short while? The next chemical for us to look at this week is a sort of crystalline blue solid. It's one that you'll become very, very familiar with through chemistry work at school, copper sulphate. I could give it a more detailed name. I could call this hydrated copper sulphate. Hydrated suggesting something to do with water. Maybe these crystals, even though I can't see it, maybe they contain H2O as well as copper sulphate. That's why we'd call this hydrated copper sulphate. Let me get my couple of spatula measurements of copper sulphate into the boiling tube. I can see lots of small crystals of quite a nice sort of deep blue colour, certainly a blue colour, crystalline. Once again then, blue crystals of hydrated copper sulphate. What's going to happen this time? We'll start by heating this copper sulphate quite gently with just a mild blue flame. And almost immediately there has been some sort of colour change there. You can see two different colours in the tube where it has and has not yet been sufficiently heated to initiate that change. But also pay attention to higher up the tube. What's going on in here? What's coming out at this end, if you're able to see it? There must be more than just the solid at the end changing. Well, the solid's changing, but one of the products perhaps isn't also a solid. And also, hopefully you can see there's an advantage to having our tube pointed off at an angle, not just for safety, not just so it doesn't fly in my face when I'm not being careful enough, but because any gases escaping from these heated solids, they're going to have to collide with the inside surface of that tube, and when they do, they might well get cooled down by the glass, and if so, they might well condense, and that gives us another opportunity to see something. So have a closer look at that now. You can see it clearly looks quite different to how it did at the beginning. Our final chemical for today is iodine. Iodine's got the chemical formula I2, which means it's made of two I atoms, I being the element iodine, stuck together. So here's a close-up of our iodine. You can see it looks like little balls of solid rather than a fine powder as we have for some of the other chemicals. Notice the colour. Just some kind of grey solid really, it's definitely grey, and those are little granules, little balls of solid is what we have here. And we're going to heat this iodine up on a little metal tray here. Now, the metal tray in question is too small to fit on top of the tripod without using some kind of fitter. So here my metal tray will sit nicely on top of what we call a clay pipe triangle. I've got my tripod, something you're familiar with. I could put a gauze on top of that. A gauze would work just fine here. However, if I use this clay pipe triangle, they're sometimes also called pipe clay triangles, by the way, then the heat can get directly to whatever's sitting on top, rather than have to warm up the gauze first before it heats up the metal tray. So the clay pipe triangle rests nice and neatly on top of the tripod, and then my sample of iodine sitting on this metal tray sits on top of that. So let's heat up this iodine now and see what happens. Here we go. Now, continuity alert, you might notice we've suddenly teleported somewhere else. The experiment is now set up in one of our fume cupboards. That's because I know that there's a sort of safety aspect to doing this experiment. I'm going to do this in a slightly unusual way this time. The iodine is no longer on that metal tray. I'm going to heat up the metal tray. So therefore we're going to heat up the iodine by putting it onto something hot. So there's just our metal dish from earlier getting warmed up. I'm sure that that's nice and hot now, so I'll turn the heat off. Now I'm going to introduce the iodine. Remember, the iodine's that grey solid, that sort of granules of grey solid here, onto that very hot surface, and it immediately turns into a purple gas, which is pretty cool, isn't it? Now, I could have heated it up with the Bunsen burner directly, however I chose to do it this way round. Let's also notice that there's none left there, and it appears that the solid turned directly into a gas. So again, a few granules of solid iodine onto a very hot surface, and it immediately turns into a gas. It's difficult to see on the camera, but there wasn't any liquid there. We can't see any iodine liquid. We seem to be going directly from the solid phase or state of matter to the gas phase. So there we are, that's quite a cool one.